Okay, now in this problem, this is the circuit diagram is here. Okay, then a series circuit consists of 25 ohm resistor. Okay, now here 25 ohm resistor is here. Then 64 millihenry inductor is here. This L, and 80 microfarad capacitor is here. Then is connected to the 100 volt. Here 100 volt 50 hertz single phase AC supply is there. Okay, now here calculate first current, then voltage across individual element. Individual element means R, L and C, that is VR, VL and VC. Then calculate overall power factor. Calculate overall power factor with respect to I. That is third parameter is cos phi. Okay, that is overall power factor of RLC circuit. And last point is draw phasor diagram. Draw phasor diagram with respect to I bar, VR bar, VL bar, VC bar and V bar. With respect to reference phasor is first current and second reference phasor is voltage. Okay, now this is the given data is here in RLC circuit. Now we have to need to find out current, voltage and individual element like resistance, inductance and capacitance, and find out power factor, that is cos phi. Also draw neat diagram for reference phasor is current and reference phasor voltage. Okay, now this is the given data is here. Okay, now first is given data is resistance value is 25 ohm, but XL is equal to 2 pi FL. That is inductive reactance is equal to 2 pi FL. F, that is 50 hertz frequency, 2 pi as it is, and the value of L is 64 millihenry, that is 64 into 10 raised to minus 3. Okay, then obtain XL is equal to 20 plus 10. Okay, now we obtain value of XL is here. Then X is equal to 1 upon 2 pi Fc. Okay, then the value of EF is 50 hertz put here. Then value of capacitance C is 80 microfarad. The value of capacitance C is 80 microfarad. This value put here, that is 80 into 10 raised to minus 6. Then value of X is 39.78. But in RLC circuit, impedance formula is Z is equal to R plus JX. Okay, now this is the impedance formula. Z is equal to R plus JX, but X is total reactance of the circuit, that is XL minus X. This is the important formula in RLC circuit. This X is equal to XL minus X. Then this value of X is put here. That is Z is equal to R plus JXL minus JX. Then put here values of R, XL and X. Then obtain Z is equal to 25 minus J 19.68 ohm. Okay, now this is the impedance here. But formula for I, that is we obtain voltage is V is equal to I into Z. Okay, then I is equal to V by Z. Okay, then phi, that is 110, that is input voltage is 110 is given in circuit. Then value of Z is put here. Then obtain 110 divided by 31.81, that is 110 divided by 3181. Okay, then obtain 3.4580 is 3.4580. Okay, but here angle phi is phi1 minus phi 2. Okay, then here phi is equal to 0 minus minus plus 38.20. Then I is obtained, its value is 38.20. That is I is equal to 3.4580 ampere. That is value of I is equal to 3.4580 ampere. Okay, now this is the value of current. Okay, now here we have to need next parameter is VR. Okay, then here I is equal to 3.4580 less than 38.20. This is the value of current here. But VR, voltage drop across resistance I into R, then value of I is here, then value of resistance is here. Then voltage drop across resistance is obtained 86.4 less than 38.20 volt. This we obtain voltage drop across resistance VR. Then same for VL I into JXL. Then put the values of I is here. This here. Okay. Now here. Then here value of I is put here. Then value of XL is already we have calculated. This value of XL is here. 20.10 is put here. This 20.10 put here. But here we have considered inductance. Okay, and we have obtained voltage drop across inductance. In inductance, first condition is current I is lag by voltage 90. Okay, first consider. But voltage is lead by current 90. Here, this is for VL. That is we have considered VL. Then we have considered voltage parameter V is lead by current 90 degree. Then we are taking plus 90. That is lead means plus 90 because we have obtained voltage across inductance, and voltage across inductance is lead by current 90 degree. Then we are taking here angle is plus 90. Okay, why taking 90 degree? Because in VL voltage lead by current 90 degree in inductance. Then we are taking leading angle 90. Okay, that is 3.4580 less than 38.20. This is the value of I is here, and we are taking value of XL 20.10. This value of XL is 20.10. Okay, it's taken here and less than 90. Then this is the polar to polar form. Then we are taking multiplication of polar to polar form. Okay, now here we have to need voltage across inductance is 69.50 less than 128.2. That means we have obtained value of PL is 69.50 less than 122.2 degree volt. Then same for BC. This voltage across capacitor BC is equal to I into minus JX. Here by taking minus JXC because XC, that is the value of capacitance X is equal to 1 upon 2 pi Fc. Okay, that means C is equal to capacitance is 1 upon X, and this value goes to the upper side, then we are taking minus X, and this is for imaginary value of inductive capacitance, that is I is equal to minus Jx. Then put here value of I is here 3.4580 less than 38.20. Then here the value of X is already calculated. The value of X is 39.78. Put here and minus sign as it is. Okay, now here the value of PC is here we are taking minus 9. By taking minus 90 degree angle in PC, this capacitor. In capacitor, the current I is lead by voltage is plus 9. But here we have to obtain voltage. This voltage is lag by current is minus 9. That is we have to consider voltage constant is here. Then here PC is equal to 3.4580 less than 38.20. Then 38.78 less than minus 9. That is we are taking 5 minus 9 because in inductive capacitance the current I is lead by voltage 90 degree, but voltage is lag by current minus 9. Then here we have to obtain voltage drop across capacitor, that is PC. Then we are taking minus. Then here we are taking polar to polar multiplication. Okay, then we have obtained angle is 134.10 less than minus 51.90. Okay, please hold. But here voltage is given, that is 110 voltage is given here. This voltage measure in volt. Okay, but here also these are the important elements. That is first we have calculate current I. Okay, then we have calculate individual element, that is VR, VL, PC. Then we have to calculate power factor, that is cos phi. This power factor, that is overall power factor is cos phi, but phi is depend on RLC circuit, that is here this is the inductance, resistance, inductance and capacitance. Okay, connected with AC supply voltage is here. In RLC circuit, current I is flowing through, that is current I is flowing through, that is 3.4580 less than 38.20 with respect to R, L and C. Okay, now here angle is given and cos phi is the cosine angle between voltage and current. Then we are taking this angle, that is I, and this angle of I is taken. This phi is equal to 38.20. This put phi is equal to 38.20. Then obtain 0.7858. Now in overall power factor, we are taking positive value, that is leading. Then we are taking negative value, then lag. Okay, now in this problem, we have to obtain power factor. Power factor value is positive. Then we are taking leading power. Okay, now this is the all parameters will be found in RLC circuit. Okay, now we have to draw phasor diagram. Now phasor diagram in which we are taking reference phasor. Now here there are two reference phasor with respect to current I and with respect to voltage. Now here this is the voltage VR. Now here voltage VR with respect to voltage. It is reference phasor is I is here. Reference phasor voltage is V is here. Now this is the VR. Okay. Now here voltage across inductance VL is here. Now here voltage across inductor VL is here. Then voltage across capacitor VC is here. Then voltage across capacitor voltage is VC is here. Then supply voltage is V is equal to 110 volt is here. Okay. Then here supply voltage is here. Okay. Now in we have considered voltage drop across VR. Angle is 38.20. Now the voltage VR is here. The angle of voltage VR is 38.20 is here. Same for voltage phasor, angle is here 38.2, that is 20 degree. Or this is for VR. Then VL angle is 120. Okay. So for VL, then VL is here. Now in VL with respect to voltage, because we have considered VL, angle is 128.2. For VC, angle is minus 51.9. That angle is here. This for VC minus 51.9. That means in reference phasor we are taking voltage is VR bar plus VL bar plus VC bar is here. But voltage is given is 110 less than 0. This is for reference voltage V. Now here we are taking reference voltage with respect to VL and VR. Now this is the reference voltage between VL and VR. That is reference voltage between VR and VL is VR bar plus VL bar. Okay, now it's here. Then reference voltage between VR and VC is V. It is here. It is reference voltage between VR and VC is V here. But the value of total voltage is VR bar plus VL bar plus VC. Okay, now this is the reference phasor is here. This is reference voltage phasor is here. Okay. Now in reference phasor current we are taking phasor taken between VR and VC is VR plus VC. That is addition of VR plus VC with respect to voltage. But we are taking VL and V. We are taking reference voltage is VR. Okay. Now this is the reference phasor diagram with current, and here VR and I both are in same phase and same direction. Okay. Now this is the concept of reference current I and reference voltage. Okay. Now this is the phasor diagram will be depends on value of I, VR, VL and VC and also V. Okay. Now this is the problem based on RLC circuit. Okay. Now this is the problem based on RLC circuit, in which first we have to need find out value of XL, XC, then find out I, VR, VL, VC and last point is power factor. Okay. Now this is the problem based on RLC circuit. Now next point is very important, that is last point in unit number 3, that is parallel AC circuit. Now here this is the parallel AC circuit is here. In parallel AC circuit we have considered 3 impedances, Z1, Z2 and Z3. In parallel AC circuit, these 3 impedances are connected in parallel with supply voltage V is here, and this type of circuit is called as parallel AC circuit. That is, parallel circuit is one circuit is defined as in which 2 or more impedances are connected in parallel across supply voltage. Then this type of circuit is called as parallel AC circuit. Now in impedance Z1, current I1 is flowing through it. In Z2, current I2 flowing through it, and current impedance Z3, in which current I3 is flowing through it. This I1, I2, I3. Now this is the parallel AC circuit. Then we have to apply Kirchhoff current law. That is I is equal to I1 bar plus I2 bar plus I3 bar. That is total addition of the current. That is I is equal to I1 bar, I2 bar and I3. Okay. Now, but important formula is V is equal to I into Z. Okay. But here we have to apply Kirchhoff current law. That is KCL law. Then I is equal to, rearrange equation V by Z. It is here. We have considered I1 V by Z1. Then I2, then V by Z. Then I3 is equal to V by Z. That is I is equal to V by Z. That is V bar Z is equal to V bar Z1 plus V bar Z2 plus V bar Z2. But Z is called as equivalent impedance. That is Z is equal to obtain 1 upon Z. Then 1 upon Z is equal to 1 upon Z1 plus 1 upon Z2 plus 1 upon Z. That is Z is the equivalent impedance. That is this is the equivalent impedance. That is 1 upon Z is equal to 1 upon Z1 plus 1 upon Z2 plus 1 upon Z. And this impedance measured in ohm. Okay. Now this is the simple AC parallel circuit. Okay, that is in which 2 or more impedances are connected in parallel across supply voltage V is there. Now here we have to apply Kirchhoff current law. I bar is equal to I1 bar plus I2 bar plus I3 bar, but I is equal to V by Z. Then I1 is equal to V by Z1, I2 is equal to V by Z2 and I3 is equal to V by Z3. But Z is also called as equivalent impedance. Z is equal to 1 by Z. This is 1 upon Z1 plus 1 upon Z2 plus 1 upon Z. Okay, now this is the concept of parallel AC circuit with respect to impedances. Now we have to explain. Next part is 2 impedances connected in parallel. Okay, now here we have considered current I1 for previous circuit. Okay, now here IT means total current into Z2 upon Z1 plus Z. Now in this circuit V is equal to I into Z. Okay, now here we have considered I1 Z. Okay, now also we have to consider I2 Z1. That is, we have considered V12 that is V12, that is I1 Z2. But we have considered V21, then we have considered obtain I2 Z1. Same here, we have considered I1, then we have considered Z2 impedance. Okay, that is I1 considered, then obtain Z2. For current I2 is equal to total current. Then here we have considered I2, then we obtain here Z1 upon Z1 plus Z. And IT means total current. IT is I1 plus I2 plus I3. Okay, now this is the total current in the circuit. It is in two impedances connected in parallel. Then we have to need total current, and also we have to need current division rule to find out current I1 and I2. That is I1 bar is equal to IT into Z2 upon Z1 plus Z. For same current I2, I2 is equal to IT into Z1 upon Z1 plus Z. Okay, now this is the concept of two impedances connected in parallel. Okay, now here same procedure for current I1, that is I is equal to V by Z. Okay, now here for I1 Z1 is here, then I2 Z2 here, then IN is equal to V upon ZN. Okay, now this is for current in individual branches. Okay, that is I1 is equal to V by Z1, I2 is equal to V by Z2, and IN is equal to V by Zn. Now here we have to need angle tan phi. Okay, tan phi, that is R plus Jx for Z is equal to. Okay, then Z1 is equal to R1 plus J into X. Then tan phi is X1 upon R1. Okay, then Z2 is equal to R2 plus J X2. Then tan phi 2 is equal to obtain X2 upon R. Then same for tan phi n is Xn upon Rn. Okay, now this is the tan phi n is Xn upon R. Okay, now this is the when two impedances connected in parallel. Okay, it is very simple concept. Now last point in unit number 3 is admittances. That is concept of admittance. What is the definition of admittance? It is symbol of admittance is capital Y, and this admittance is reciprocal of impedance. That is Y is equal to 1 by Z. Z is equal to 1 upon Y. Okay. Now here Z is equal to Z impedance measured in ohm. Then admittance measured in Siemens or ohm. That is Siemens and mH. Okay, that is the impedance and admittance. Okay, this is the concept of admittance and impedance. Okay, now here we have to need current equation. That is I bar is equal to I1 bar plus I2 bar plus I3 bar. Okay, but V is equal to I into Z. Okay, then I is equal to V by Z. Then for current I1, it is V by Z1. Then for current I2 is equal to Z1 V by Z. Then current I3 is equal to V by Z. That is, I is equal to V into 1 upon Z1 plus V into 1 upon Z2 plus V into 1 upon Z2. But 1 upon Z1 means 1 upon impedance means admittance 1. 1 upon Z2 means Y2 is admittance. Then 1 upon Z3 means Y. Okay, that is here V bar, that is V into Y, that is voltage with respect to admittance V Y1 plus V Y2 plus V Y2. But Y is equal to Y1 plus Y2 plus Y3. That is, this is the equivalent admittance. It is Y is equal to Y1 bar plus Y2 bar plus Y3 bar. Okay, now here, and Y is the total admittance of the circuit. That is, Y is called as total admittance of the circuit with respect to admittance 1 upon Z1, 1 upon Z2 and 1 upon Z3. Now, this is the parallel impedance circuit is converted into series admittance circuit. This is the parallel admittance circuit Z1, Z2 and Z2. With respect to voltage is AC. But Y1 is equal to 1 upon Z1 because this is parallelly connected. Then 1 upon Z2, then 1 upon Z. Okay, now this is the concept of parallel impedance and series admittance. Okay, this is the last point in unit number 3. This concept of admittances.